Cool. So programming a guessing game. And we're actually going to go through and do every single command that it gives us so that you can see, like, I'll probably definitely make mistakes along the way, and that's all part of the learning. It's good when you see presenters make mistakes, especially if you can spot the mistake before they do. It's even better. So this guessing game introduces you into a few common Rust concepts by showing you how to use them in a real program. The good thing about this game is that it's not too much pseudocode. You can actually use it. You'll learn about let, match, methods, associated functions, using external crates, and more. External crates are basically like NPM packages.
Okay, cool.
It's like that's Rust's term for modules, I guess. The following chapters will explore these in more detail. In this chapter, we'll get the fundamentals, and we'll implement a classic beginner programmer. We'll implement a classic beginner programming problem, a guessing game. The program will generate a random integer between 1 and 100. It will prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too high or too low. If the guess is correct, the game will print out a congratulatory message and exit. Sorry, I don't know how to say that. Right, so the first thing. Are we all following on, by the way? Like,
yeah.
or not?
Yeah,
no, that's not. You don't have to, but it's just interesting if we all are. Dwayne, so if anyone hasn't actually got Rust installed, actually we're going to be missing a step, which is Rust.
Install it, right? Yeah.
Oh, everyone's got that then, yeah?
Installed, right?
Well, the best way to test, if you look at my screen, is just to type Cargo. If you get that, and you'll come on if you have it installed.
It's somewhere.
Damn, Cargo.
Yeah? You got Cargo?
Yeah.
Ah, right, okay.
It said it installed it, component Cargo. So
Have you created a new terminal session?
You're gonna go for it.
Just do Command T on that window and just go.
Yeah, that's it. Can I just use the one?
Yeah, start again. Yeah, just type Cargo now. Yep, boom. So what's happened there is you've installed it in one session, but it hasn't updated like all your environment variables and your paths and stuff like that to include.
Yes, sometimes crates just work. Okay, how to use extend credit so you can use the completions of the crate things.
What's that? Visual Studio.
And then on the Rust Playground.
All right.
Use the top end crates.
Ah, didn't know you could use external crates on there.
Either.
Nice.
Yeah,
it's pretty cool.
That's cool.
So it's just going to be following along doing that because it doesn't have the Rust install.
Yeah, cool.
Fine.
For the rest of us, let's just go ahead and just.
It won't work because it needs to have it.
Yeah.
Yeah, but we can always just fake that with a string or a string slice.
Yes.
Anyway.
Cool. So first command, pretty simple. Cargo new is like the way of sets up a standard boilerplate for a program, and it will create an actual application for us, which basically just differentiates between a library and an application. And this one will be set up to be just something you're going to run on the command line, which is perfect for this. Then, so did you run that command, Dwayne?
It's a Cargo new.
Sweet.
On a new folder.
Well, just run it anyway, because that'll actually create a folder matching the name of the project you give it there.
Okay.
You can actually initialize a project in an existing directory, but this is easier.
With Cargo in it.
Yeah, Cargo init inside a folder will not create a folder, it will just do it in place.
Yeah.
That'll create a folder, yeah. So now if you go cd guessing game, now we're inside there, and
So you could take a look at the Cargo.conf file.
yeah, I got that on here. Oh yeah.
Cool. I mean, guessing it. Yeah, so that creates like the name of your package, your author, and if you have any dependencies. That's where we are.
I think we're going to get to that. I think there's a piece. Oh yeah, it's the next one. Yeah. Cool, yeah.
Getting ahead of myself.
Diego, you're right on track. Cool. So that only created 2 files there, and they're quite interesting. So the TOML file is For JavaScript people, that's like having your packages.json file.
Yeah.
PHP is like having your composer.json file.
Yeah.
And so literally it just gives us a source folder and that TOML file. And in there is just your name, the version, and authors. All just boilerplate stuff. You never really touch this stuff after you've created it the first time. But crucially, it has like this dependencies key here, which has got nothing below it. So this file format, love it or hate it, is, yeah, basically there's no dependencies at this point. So we'll see what happens when we come back to that. And when we created it, it actually gave us a source main file. So I'm going to open up in my editor now. So I just go pstorm dot. Oh, not that. Not that. In fact, none of that. I'm just going to quit this and let it open it up in the right place. Well. Okay, so let's get this maximized. If you open that folder up, you can see that we've got the TOML file, git ignore, don't need to really care about. Oops. And then we've got our main.rs file. So it actually gave us a working program. So what's interesting about Rust for people who have not done statically typed languages before, sorry, I'm just going to ignore all my IDE files, is that like Rust, because this is an application, as they call it, or a binary, they look for this main method. It's like the entry point into your application. So you can't really, like if you had a line that was here, for example, I think that would actually be an error. I don't think that would actually work. Is that right? Anyone know the answer to that?
I don't think that would work.
I actually don't know. I know you can have like you can have const declarations and stuff like that up there, but I don't think you can have actual executable statements.
Yeah, like maybe points has to be an actual value. Have like a function.
Yeah. Okay, so let's look at the next bit.
But anyway, that's the entry point of the application.
Yeah, the point there was that this FN main is extremely important because that's the entry point. And does it tell you how to run it here? Yeah, so now we can run it just by typing cargo run.
So that's quite different to PHP and JavaScript.
Yeah, that's right. Yeah. Because, you know, with Rust, you're going to be typically writing programs that are executed via the command line. And whereas in the stuff like JavaScript is, you know, it's got its own execution model, I guess. You know, files get executed in order as they're seen in the HTML, stuff like that. But with Rust, you need somewhere for the program to start, basically. And that's what that is. It's better. Cool. So I'm guessing you've already typed it, but cargo run. There you go. Hello world. Nothing too exciting about that, right? But it has given us that base knowledge of what a cargo.toml file is, how to create a new program, and what the entry point is. So you can't get any more. Hello worldy than that. Next thing. Any questions, by the way, so far?
No, that's good.
I mean, we're not even going to go into why print line has got an exclamation point there, but that's going to be for other weeks. So it says the run command comes in handy when you need to rapidly iterate on a project, as we'll do in this game. So it's like basically a helper. It's like cargo will temporarily create like does it actually put the binary in the target? Yeah, so it will actually create like a debug. So a debug target, which is essentially like compiling it, like when we compile our JavaScript.
Yeah,
it's essentially doing that, but in a debug style. So without all the optimizations that would happen in production, and that's why cargo run works, because we've got this output in this directory here. So, onto an actual program. The first part of the guessing game will ask for user input. Process the input and check that the input is in its expected form. To start, we'll allow the player to input a guess. So we need to enter this code. So we'll copy paste and then we'll go over each bit. That's a good idea. So line by line. Everyone got that in there? Yep. Anyone like the theme, by the way?
I love the theme.
Yeah, your theme is nice.
And the
I
terminal
don't
as well.
have a theme for that.
So I'm just going to quickly just scan ahead just to see what they actually talk about here because I don't want to doubly cover everything. Oh, actually, yeah. So let's follow as it says in the book because they are going to do exactly what I was going to do there. So let's go line by line. So this first bit, use std : IO. This code has a lot of information. To obtain user input and print the result as output, first thing we need to do is bring in the IO input-output library into scope. The IO library comes from the standard library, which is known as std. You'll get used to Rust's all about making things shorter. FN instead of function, std instead of standard, and it goes on and on and on. And this is quite an interesting bit. By default, it only brings a few types into scope of every program, called the prelude. If a type you want isn't in there, you have to bring that type into scope explicitly with a use statement. So it's a bit like having globals in other languages. There are like there's some globals that are already there for you to use. But in this case, because we're doing this, where do we use IO? Yeah, we're doing this standard in here, which is reading input. That isn't included in every single program by default because you may not actually take any user input. So it's all about keeping it lean, I guess, and not including things you don't need. And it just says this library provides you with a number of useful features. And as we saw in chapter 1, the main function is the entry point. Yep, we've been over that. Probably worth just going over that, like the syntax there. I guess it's quite obvious. You know, you're used to seeing basically function. In Rust, it's just fn. And same thing, parentheses to contain any arguments. Yeah, parameters. But in this case, the main never has any. And actually, you would get an error if you attempted to use any. And yeah, and then curly braces to define a block or a code block. In this case, you would call it the function body, I guess. Any questions on that? It's pretty straightforward, that bit into.
It's slightly a tangent, but can you get argv?
Yeah. Basically, there's IO, env, args, I guess. I don't know what the exact thing is, but yeah, you can absolutely get a iterator of all the arguments. Then it says, right, so let's look at the next line, this print line. So for the JavaScripters out there, where you would do console log to get something into the console. This is the equivalent in Rust. Again, we don't want to dive into why this is here, but you can just think of Rust having some like global helper functions. It's the best way to think about it. These are actually called macros. So when you see this little exclamation point here, it means you're using a macro. And that's used. It's used for metaprogramming in Rust. So it's like something that would normally take quite a bit of code to do. Often it's just made more succinct and shorter by using a macro. So yeah, so that's the equivalent of just doing a console log there. So we're going to expect to see guess the number, then a new line. So that's the other bit, is that you can have print or print line. This will insert a new line character at the end of every string. Yeah, definitely the end, not at the beginning. So that's why we use print line mostly, because we get to see things nicely on line by line. And that's what those two do. And I'll just defer to the book for the next bit. Any questions on printing to the screen? Pretty straightforward, right? That one.
Yeah.
You can do some cool stuff with that as well, which we'll get to later. Next thing, storing values with variables. So if we're going to take the guess in, we need to store it somewhere. And we have this line, which is going to be very, very strange to some people. Let mute guess equals string new. What the book says about it. So it says this program is getting interesting. There's a lot going on in this little line. Notice how there is a let statement, which is used to create a variable. By the way, if anyone thinks I'm not reading correctly, I don't. I've got this weird thing where I don't actually read. I'm scanning over it and just saying it out how I read it. So it's not going to match exactly. But here's another example. So the main thing here is that this line here creates a new variable called foo. So on the left-hand side, that's creating a variable and binds it to the value of the bar variable. So this is very similar to all the languages we've all used before. Nothing too scary there. One thing to mention is like it's always let. If you're going to do if you're going to have any variable, no matter what type it is, it's always let. So like in JavaScript, we can do var, let, const. PHP that's done for you by a compiler, I guess. So you don't even say what it's going to be. But in Rust, it's just let. Sorry? Yeah, but that's not for a variable bind. Oh yeah, I guess it is actually.
There's some usable things that are computed at compile time.
Yeah.
It's not like const in JavaScript.
No, absolutely. So yeah, so there is const. Yeah, so I'll take that back. I don't know if we'll not probably get to an example of that, but probably one to keep in mind. So yeah, this line creates a new variable. The following example shows how to use mute before the variable name to make a variable mutable. So this is definitely one of the interesting parts. I don't know whether to like stick here for a second and talk about it or just follow the book. Like, what does everyone think? Do you think we should just carry on and read it, like kind of read it through as we go? Because it is, I'm just going to end up repeating everything that's there.
More detail in chapter 3 about mutable and immutable. If you wanted to find more about what mutable and immutable. Yeah, so
yeah.
Yes, you could go on to chapter 3 if you really wanted to.
I think discussing it a little bit may be better.
Yep.
Because
it's when
but if we get some conversation right.
Yeah. Cool. Let's do that. Yeah. Let's get. No, that's great. Yeah. So let's get some things running as well then. So that example was, yeah. Let's copy that. If we just have that, and then we try to print line. Okay, going to get exactly what we expect there. I'm just going to stick this over the other side. 1 sec. Make this bigger. Stick it there. Move that there. Right. So yeah, so we've outputted the number 5 there, and then if we wanted to change that binding to be a different integer like 6. You can see straight away it's like red squigglies, and that's going to come as a surprise to people who've just done the like dynamic languages. If I run it, it's going to be like no chance, bro. And let's read the error. Sorry.
So everything is immutable by default. You can mute it anywhere at all.
Yeah. So the binding is cannot assign twice to immutable variable foo. That brings the question of like, well, it's not going to be a very useful programming language if for every value you can't ever change. So, good thing to note here is the errors. If you look in the, you should really take like these errors. There's so much time and effort put into these to make them like readable. So descriptive. Cannot assign twice to immutable variable. even shows you where the first one was. It's like shows you both line numbers, so really, really useful errors. But the problem there is that, yeah, it's not mutable by default. Adding the MUT prefix to a variable makes it mutable. So this is one of Rust's ways of ensuring that kind of you're explicit about your program's needs in terms of immutability. That might not seem like super effective right now, but imagine when you're passing code from one library to another and you've got nested functions and you're working on different threads and all sorts of things like that. This safety, yeah, it's essentially a safety feature of Rust to ensure that, I mean, when we get further on, you'll see that especially not having two references to the same mutable thing is a good thing, to not be allowed to do that. But have I missed anything fundamental on that? Does anyone think? You know, like I'm just babbling out loud. The yeah, just to refresh, basically, this creates an everything's immutable by default, and you have to explicitly opt in to mutability. That's the key feature there. Does everyone even understand what we mean by mutable and immutable in terms of variables?
Changing or not changing.
Oh, it's the ability to change later.
Yeah.
Cool. So now you know, let mute guess. So yeah, now we can go back to the code that was there before. Now it makes more sense.
I need to declare an empty variable.
No. Depends what you mean by empty. Depends what you mean by empty.
I've seen some stuff where you can, some languages where you can write something like let int a and then stop there and use a later.
Yeah, no.
You can't do that. It has to have a value,
Yeah,
even if the value means it's empty.
yeah. So there's constructs for explaining the presence or the absence of values, but you don't do it by not assigning a value to a variable. I know what you mean. Like in JavaScript, you sometimes have like 10 variables in a line. They're all like just the names of the variables, but with no, essentially they've got a left-hand side but no right-hand side. That's what you're saying, isn't it?
Technically in JavaScript, you said null, which is still a type, I think, in JavaScript.
I think they'd be undefined. Yeah, I think they'd be undefined in that case, which is, you're right. You're right, yeah. You're absolutely right. So you are.
So it doesn't have no. Rust doesn't have no undefined.
Yeah, we'll probably cover that later with the default function.
Just to add to what you said, like you declare a variable foo that was equal to 6, right?
Yeah.
So if you never want that to change, why would you make it mutable? In other language, you can't really choose.
Yeah.
But if you just make it immutable, then you can rest assured that that's never going to change. So that's a good thing.
Yep. And again, I would say that for primitive values like this, like numbers and integers and strings and things like that, it's not too important. But for, you know, when you can guarantee that no one's going to touch a vector that you're iterating over, for example, that's a really good guarantee.
So what we were saying about declarations, strong test in the background, you are allowed to declare a variable without assigning it as long as you assign it to do anything with it.
Ah, right. That's cool. So it's like hanging around until they can figure out a type. So then they come.
Yes, so I've written let x colon I32.
Hang on.
Specify types.
I'll type it out. Hang on, so we can see it. So let x and then nothing after it. Yeah.
Let x colon I32.
Oh.
You might actually not.
That's what I was going to say, because if you've got to declare the type, in my eyes, then you might as well have given it a value. But yes, so we try it without even a value.
Yeah, that's right.
And then if we try let, surely, hang on, oh, this is interesting. I mean, if this compiles, then
So it will just infer the type from the assignment of the density.
nice. Yep, so that works.
But then what happens if you put that in a time?
If, what do you mean?
If false.
If false.
Yeah, and then stick nothing. And then print ln x.
Down here.
Yeah.
Oh yeah. So this won't work then, will it? Because it's not going to be able to infer the type of every code path. Well, I'll guess this won't work. Yeah. Through the error. Use of possibly uninitialized variable.
It doesn't allow.
Well, yeah, I mean, it's a bit like a closure. Like if you've ever done a closure and you don't use the closure, and you've done something like you've got there, and it can't figure out all the types. So it's like sometimes it's the usage that has to create the.
Well, if you assign that time,
It's
it
called
work
that it's called that it catches like errors that you haven't.
Oh. It ain't gonna work, yeah, because like I said, the problem is Rust is protecting you here because you may not enter this if, which was the whole point of your demo.
Yeah.
Like you may never enter here, in which case it can't initialize into that. So you'd have to do this,
Yeah.
and then still do it something that matches that type. Which in this case, then it's pointless, isn't it? You might as well just initialize it as a 0, like that.
So even if you have got VFLs, you can just write base x equals if condition 1 else 2.
Oh yeah.
Well, it's not very useful, I guess, but it's interesting. To know.
Oh, hang on. Were you talking about using like the result of VF?
Yes.
Yeah.
Oh yeah.
Yeah, that is nice. Yeah, that is something that you just we don't get in any other languages. So if we were to say let x equals if false, and then else. Oh, sorry. Or like that.
No, the first x will be 10. Actual value. In the first.
Oh, sorry. Yeah, hang on a sec. Get rid of that. Because this is like it's guaranteed now to be. Is that what we're saying?
Yeah.
Yeah. So it can look at it's smart enough to go into both branches.
Oh.
It's cool.
Because
The
is a expression instead of a statement.
Yeah, that's the
Like
bit I was
the
going to say. Like that's the mind-blowing bit when
So
you're
you
coming
can
from JavaScript or something. It's like, I love that. Well, and you have to do it as well because they don't have a ternary operator. So you end up, sometimes you just want to do a really succinct line of code and you end up doing that. Like if you want it in a one-liner. You know, that's essentially the smallest way, I guess, to do it in Rust, other than if you wanted a...
Well, you can go with the braces. One question
I don't think you can you?
That parentheses.
Oh, the parentheses, sorry. Yeah, but you can't get rid of the braces.
No.
Like I'm saying, like normally you're used to seeing that in every other language, just about like a little ternary operator. I actually think it's more readable. Yeah, we're gonna keep fanboying on Rust, so we'll say it's good.
I think it tells you to take the brackets out, actually.
Yeah, I think it would. Yeah, I think that's what that arrow was saying.
Well, it is
There.
here on the right side.
That arrow was saying, yeah, it was sweet.
You know when you
That's
print
nice.
it and you print with the brackets.
Yep.
Yeah.
Okay.
So think of this as like a little placeholder, and then to the right. And what's good about this is that it's checked for usage. So this would actually fail because you've not provided a second argument.
So it's like don't be stuff.
Yeah. Like and then this has got there's like special inside there. This special.
Print that folder.
Yeah.
In JavaScript.
But crucially, this is way stricter because you can't get it wrong, basically.
So you can put normal text next to that placeholder.
Yeah, like
So
it can be this.
anything, and then the variable will go to inside the placeholder. So you can
then
format
you
your
get-
text however you want.
And you get the
With
0.
multiple arguments and so on.
Nice.
But crucially, you couldn't do that. So essentially, you couldn't try and do a string and then forget that you've not given the second argument because it's going to blow up and say nope. That's because that macro behind the scenes is checking that the usage of placeholders matches the arguments passed in, the length
It
of
has
the
to
argument.
be correct.
Well, I won't say correct, but yeah, correct as poss.
Yeah.
Cool. Cool. So that was a bit of a good deviation. Love those natural conversations that come out of it. So if we go back to where we were, So now we know that let mute guess introduces a mutable variable named guess. On the other side of the equal sign is the value. Again, that's just like other languages, which is the result of calling string new, which is a function that returns a new instance of a string. A string is a type provided by the standard library that is a growable UTF-8 encoded bit of text. That's all a bit, don't think we should go into that too much right now, because it's a very complicated topic. You just have to know that in Rust is a lower level language than JavaScript and other things, so you have to deal with strings a bit differently. That's the best way to say that right now, I think, so that we can make progress. Yeah, the syntax there is probably the best bit to talk about. So you can think of this is like a module or a namespace, and the colon is like accessing a member of that namespace. And in this case, it's a function. It's called new. So that's essentially what that's doing. It's a bit like if you've ever done just a dot in normal things, like from a module or something else external. What's cool about Rust though is that you can do nested things, nested namespaces and stuff, which is cool. But right now, I just know that this is a namespace in the language string, and it's got a new method that creates a new string.
We were saying earlier this is quite similar to PHP static.
Yeah. Oh yeah, because of the use of the double colon. You mean and the fact that you're not tied to an instance or anything.
But the meanings are somewhat similar, but there's edge cases.
Yeah. So the new function creates an empty string. I'm going to speed up a bit, I think, because what time are we aiming to finish? Just roughly, just so I know how to progress with this, because if you look at the scroll bar on the right, we're only just like right there. Okay, we'll just
38.
we'll just carry on.
You said 6 to 9. That's what the time is put on.
Oh, anything. Yeah, any time for me. Yeah.
9 is fine.
9 is fine. Yeah.
Cool. So if we get to the next bit of actually reading some input from the user, let's go straight to that. So this bit, it's like creating a little holder or a placeholder for a string, and the next bit is actually going and accepting input from the user. So we saw that double colon before. We see it again here. So now we know that this stdin, standard in, is a function that's from that namespace, because we've just, that's every time you see the double colon, look to the left, that's like the part of the, I mean, because if you look, so just to make this really crystal clear as well, you could actually get rid of that and you could actually put it directly there.
Yeah.
So you often see this double colon is essentially walking down a tree of, like you're walking into the module and it goes deeper and deeper.
And the reason you don't need to import string is because it's part of the prelude, right? And it's imported by default. So you get like the most used things.
I don't know if that was right, but
I imported by default for that.
Okay. So this is a function call that returns a struct that has a method on it called readline. Again, we don't need to go into the details of what any of that means right now. But what you do here is you pass in your string variable so it can write to it. So I find things like this a bit backwards, but that's the way it is.
Called buffer, right? You create like a buffer, which is the string, and then you pass in, and the function fills it in for you. That's why it needs to be mutable, because it needs to fill it in. Yeah. So you're essentially exactly So you're passing it into the read line, and whatever that is behind the scenes. Again, don't want to go into too much detail, but whatever that's doing behind the scenes, it's gonna change your thing. That's why you have to first create it and define that it's mutable here, and then also pass it in as mutable as well. So you see how explicit it is. Like you have to set it up. After everyone's first done a hello world in Rust, anyone can just look at this code and know for a fact that that guess variable is going to be modified on the fly. So that's that. It returns a result, or is it a result or an option? It's because it's expected. It must be a result. Yeah. So it returns a result that we unwrap. Again, it's tempting. I don't know how much to go into each bit, because it's like we can end up talking for an hour on every bit. But essentially, if this read line fails,
then it's going to print this to the screen. It's very unlikely this will fail in our example, so I think we'll just skip over that. Then it says you guessed. So crucially, the best way when I was reading through this is to think that this actually is going to stop and wait for us to type something, and then your program's going to continue only after it's got some input. Crucially, a line. So the way it works is your terminal, you type something in the window. When you hit enter, it sends whatever you've got to the left and the enter key, being a new line character, to the Rust program. Then, as far as this is concerned, this says, oh, well, I've now got a line, so I've done my job. So what you can also think of is this only means the first line as well, up to when you press the enter key. And the guess would have been modified, and then we just print it. Okay, so let's actually do it. Get in there. Over here. Cargo run now should. Cool. So you can see it's paused. It's given us the two outputs, and then we're going to type. I'll guess the number. So type 0, and tell us what we guessed. So the crucial bit there is to look that it's paused. You know, it's waiting for the input. We guess 0. Cool. So that's the first bit of the game. We've now got the input. So the job of, sorry, go on.
No, I'm just going to say that it's going into result later.
Yeah, that's great. Yeah, that's why I don't want to. The ampersand indicates that the argument is a reference, which gives you a way to let multiple parts of your. Okay, so I think we have to skip over all the details, otherwise we're never going to get to the end of this example. So I think we should just probably just quickly go over what a reference is, but then continue. So.
It's probably sufficient to say that when you declare a variable, the guess variable is the owner of that value. So in Rust, values have owners. If a value can only have one owner, at least in standard Rust.
Yeah.
And then when you want to give other, like a function or someone else, access to that variable, you pass a reference. Because if you don't pass a reference, you are actually giving the value to that function, and you can no longer use it because you've moved.
Into the function scope.
JavaScript has this, it's just not apparent. Like when you passed an array in JavaScript, it will pass a reference to the array and not the content.
Yeah, but crucially there, but the difference there is in JavaScript, the place where it was passed in and the new place could now both modify that.
Yeah.
So the differences in Rust is when we say. So if you pass a reference, that what I'm trying to say is when you forgetting the reference for a second, in JavaScript, there's no way to say that there's only one piece of code or one piece of scope that owns something for safety reasons. Like you can't do that in JavaScript.
You want to run what you just wrote.
Oh, this bit here.
You modified it, right?
Yeah.
Can you look?
No, because the it required. Yeah, that's the great point. Yeah. So the type system and the language itself is enforcing that the constraints on your program basically, so you can't get things wrong. So in this case, it has to be a reference and it has to be mutable. And now it will compile, and it's going to sit there and wait. But yeah, that is totally this. Yeah, in JavaScript you pass references around, but then the danger in JavaScript is that any one of these references, you could have one array or objects in the same way as well. So everything's by reference. You could have 5 things that all point to the same reference, and then some AJAX request goes off, and then like something modifies it, and the bit where you passed it, you didn't know that they modified it, and it's happening.
It's definitely a real problem. Like I ran into
Absolutely.
it. There's a reason I know it happened, and it's because it broke my code.
So that kind of thing just does not exist in Rust. Maybe it does, but it's used unsafe, but it's a different topic.
I want
So-
to use Rust, but I want to skip everything that makes Rust useful.
Yeah. So it says we're not quite done with this line of code because we get to see this expect, which is what I talked about before. It's really just a way of saying
Rust often returns values that are wrapped up in a safe way. And expect is just one way of pulling that value out. It's like it returns a box to you. Yeah, like an actual box with something inside it.
What does the I got missed it, but what does the single dot syntax do in this case?
That's just like that would just be an accessor. So
it's method calls actually.
but it can also be for properties. It's not just for. Is it? Am I right? Yeah.
Yeah, it just doesn't really have. It does have properties. It has fields and strings.
Fields. Yeah. Sorry. Yeah. Fields. So
Not like C# where you can have something that looks like a variable when you access it actually does something.
yeah. Well, that's the same in JavaScript. Yeah. You can have code that runs on access, but yeah. As far as I know, that doesn't exist in Rust. But yeah, when you see dot, it's like just saying object dot name, or you could also do object dot and then function call like you see there. Expect being a function on a result. I feel like we should just skip over the result bit for now. But okay, let's go through it.
Yeah, I think it might be worth explaining a little bit because we're gonna see it everywhere.
Yep.
No.
I think what you were saying about it being a box is a good example in that like you can only use the value that is inside the box after you unwrap it. You know?
Okay, yeah, let's do it.
Schrodinger's cat. You can't.
No, you're
can't
right.
check
Let's
the value of the cat until you like open the box.
Let's do a really quick example because it is a fundamental thing of Rust. So let's say we had number is equal to 1, right? Now, if you wanted to use that number anyway, you just access this variable, right? You don't need to do anything fancy. So if you want to print it, as always, we just go no. Sometimes you'll do something that it gives you a value, but it's wrapped in a special type. That's like it's there to allow you to reason about possible failures and possible absence of code. So there's a number of different types that allow this. One of them is that we're going to look at in a second is the result. So it would look like this. So someone would return something to you that was like a we'll call it num wrapped. Can you create just a result on the fly with a value inside it?
Okay.
Oh, just like this.
Yeah.
So if we
But you can
let's just do that so it's obvious. Yeah. So this is like an enum variant, which we're not going to get into, but essentially, sometimes people will give you a value back. So you see here, it's got the value of 2, and you can think of the code that's wrapping it there. That's like the box, I guess. It's like it's returning it to you in a way where you can reason about it, because it might return you a 2 in with an OK, or it might return you a 2 with an error, for example. So,
so you have to declare the type of this value as well, because it can't infer what the error type would be if you only got an OK value.
oh yeah, that's a good point. Yeah. So let's compile that and see if that's the case, and then I think we can use that underscore trick that Jonathan showed me. Yeah. So, oh, hang on, it's just saying that it can't do it because display. I think it might.
Yeah.
Cool. Type annotation needed, right? So that's just a quick diversion. So if we go result, what's the? Can you still underscore in that case?
I think so.
This is basically saying compiler, you try. Let's see. Let's make a bet. Who thinks it's going to work?
I think it will still say I can't infer what the error type would be.
Yeah, it's not
I think you're right. Yeah,
smart. That's not AI.
yeah, no, you can choose the right hand side for EML and then the underscore for that.
You can choose a pair of graphics to indicate that there's nothing to go in the error.
There's a string for there or string message for.
What do you mean that? So what's the smallest number type that I can use for that too? Just like a.
Underscore.
That's not going to work.
Oh, yeah, that will work, yeah.
Sweet.
That means anything.
So the underscore is I'm guessing you're basically telling the compiler there, try your hardest to infer that, and then you're saying that there's no error is that until you declare it, I guess.
So it just means that in this case it's a result where if it's an error, there's no information in the error.
Cool.
So the paragraph represents the empty type.
Nice. Perfect. So so that's a bit of a deviation, but it's a different topic, but it's just to say that in this case, so how could we show that this num wrapper can't just be used as a regular number? I know. So let's have
It's just trying to one reason. Another.
Oh yeah, no, that's better. Yeah, that's what I was looking for. I couldn't think on top of my head right. So if we try and add, even if we make it mutable, I mean the whole thing is going to because it's all just going to blow up. But it'll just add one like that.
That doesn't work. I don't think that's syntax.
What's Rust's way of just like appending one?
So plus equals does work.
Oh, does it? Okay.
And it's not going to work, and it's basically because
On result. Yeah.
the type. Sorry, there's a way to make this larger, but let's wrap this as well. So essentially, so some libraries will give you back a result, and you actually cared about the 2 here. We want to add 2 to 1, right? That was what we tried to do here. So to do that, we would have to unwrap it, and that's what the expect thing is. One way of doing it, which is not a good way either, but it's a good way to get through the first demo of a book.
So it will crash the program if it's not an okay inside.
Yeah, exactly. So, like, in any lines following it won't execute. So, you wouldn't use it to like handle mission critical errors from something. But in this case, actually, it's quite appropriate in this case because we're doing a small CLI tool, and you want the error to just come into the the line there. And I guess that's it. Cool. It's a big topic. Unwrapping values from errors and from results and options is a big topic. So I think we can just leave it there. Just know that when you see expect, you're unboxing something. Okay. That's the best way to think about it. Unwrapping it. Yeah. Because the result type. Oh, right. So it does go into it. The result types are enumerations. The variants are okay and error, which we just covered.
But also there in the prelude as well. So you know how we were saying that you can use it okay and error.
Yep.
Without having to prefix it as you did earlier.
Yeah.
They're all in the prelude. So you've got result and you've also got error and you've also got okay.
And you've got and some
result, colon, error.
Yeah, and you've got some and none.
Yeah.
For the options as well. So it says here, look, the instance of IO result has an expect method that you can call. If the result is an error, expect will cause the program to crash and display the message that you passed as an argument. If the readline method returns an error, it would likely be the result of an error coming from the underlying operating system. So I can't even think what would cause that, but yeah. If the instance is okay, expect will take the return value that is holding and return just the value so you can use it. So that's what I mean by the unboxing. In this case, the value is the number of bytes in what the user entered into standard input. Let's just do what it tells us there. So if we don't have that line, we'll try and write to it. It says we're going to get an error. That's still running from before. Oh, hang on. If you don't call expect a warning, sorry, that's right. So often you just get these warnings in Rust. It means the program will still compile, but you're probably doing something not the best way. And the error there is saying that you haven't used the result. So it says unused result, which must be used. When you're learning, everyone turns off the errors, and then the first time you try and write a real program, you're like, damn, got to put all those errors back on. So yeah, it warns you when you're not using the result. And the right way to suppress the warning is to actually write error handling. That's the funny bit. It's like, but since you just want this program to crash when a problem occurs, just use expect. So yeah, actually what you end up seeing in real world code is expects are used quite a bit in like the main entry point, just because like if you try and run something without a configuration file or something, you often just want to kill it straight away. But it's very rare you see it deep inside stuff. So yeah, onto printing values with print line placeholders, which is what we've already covered actually, but we can just run through this. You can see the example there, the 2 curly braces. It always seems odd to use 2 curly braces, but it becomes more useful later when you see that inside the curly braces you can have small, like a special syntax for saying print this in a debug style or print it in, I think you can do all sorts of things inside these 2 curly braces. But when you first learn in Rust, just know that kind of creating a little placeholder.
Yeah.
But there's some cool things, again, don't want to cover everything there. The line prints the string we saved the user's input in. The set of curly brackets is a placeholder. Think of the this is funny. Think of it as a little crab that holds a value in place. You can print more than one value using curly braces. This is what I was saying earlier. Crucially, you know, they have to match the amount of arguments you pass to the right there.
Cool. Yeah.
And that's enforced. Think of the amount of times in JavaScript when you've tried to do a console log and you do like 3 things comma separated and like one of them wasn't there and it's just a mess. Save you from that. Cool, so let's test the first part. We've already tested it actually, so we can skip over that bit.
Yeah.
Now, it's going to get interesting. So generating a secret number. The secret number should be different every time, so the game is fun to play. That's an opinion, I guess. Let's use a random number between 1 and 100 so the game isn't too difficult. But Rust doesn't include a random number functionality by default in its standard library. However, the Rust team does provide a rand crate. So that's something that's quite often in Rust. Is a lot of them are even maintained by the people who build the language. A lot of the default crates that you end up using. So this is basically saying you can't do random numbers from a standard library, so you have to go and download a crate. So this brings us on to how to work with external dependencies. And we go back to that cargo toml file. And my editor will probably just automatically install it, but we'll go in here. Oh, not very good highlighting for this file, but essentially I'm just going to copy paste this line. And my editor is going to go and get that thing so it can provide syntax highlighting and stuff for the methods that it has and type information, I guess.
Yeah.
This is just saying something about the toml file, that everything, you know, it's a thing for us web people. We don't really see toml files that much, but basically it's just the square brackets denote a header, and then all the items that follow a header up until the next header are its items, basically. Yeah. Cool. So we don't have to worry too much about that. It follows, well, they say it understands semantic versioning. I would say that's down to the library to whether or not they've stuck to it, but I won't cover too much about that. It's just basically a versioning that you used to seeing in all of the package managers, major, minor, and patch releases. Actually, it's probably worth saying that if you're going to install one of these yourself, you don't really just copy paste out of a book, do you? You're actually going to go to crates.io and look for it. So you'll go in here and you'll say random. Give you that, and then it even just gives you this like copy pasteable. You can see there that there's a newer version, so copy pasteable. I'm not going to copy that version in because I know the book works with that version, so I'm just going to leave it in there, but that's how you would find a package.
Crates.io is like the main repository for that you go to find crates and libraries.
Yeah.
So very handy.
Crates.io.
There's a new one now, but crates.io.
Yeah. I don't know what the difference is. I think it's just search differences or something.
It
just looked worse.
Yeah.
Like no one thought you could ever get worse than crates.io, and then these guys were like, "Hold my beer, bro. We can make this look way worse." Look. Now I can see searchable. Like, yeah, okay. It's not too much into that, and it's an external dependency. So don't need to, this is all pretty standard stuff for people who worked in any other languages. It creates a log file by default, so we get reproducible build. So whatever you installed it and ran with locally, if it worked locally, then it should work. You try and compile it. Log file, blah blah blah. Actually, crates.io was inspired both by Ruby's package manager and JavaScript's. When you listen to the people who built it, it's like, yeah, they took the best of the Ruby world and the JavaScript world and made it better and just iterated on it, I guess.
So it's like, we don't want this language anymore, we want something else.
I think yeah.
So actually, there are people who actually use WebAssembly, so you don't have to write JavaScript as well.
Yeah, we've been doing. Yeah, that's what we've been doing. That's what we're trying to do. I'm surprised C# have got an entire library out now that does it as well.
I think the problem is you end up having to put the entire .NET runtime into your web page.
Well, yeah, and same with Go, isn't it? That's what someone was saying on a podcast I was listening to. Like, yeah, you can do Go already, and they're like, yeah, but you actually end up compiling Go's entire garbage collector and everything into WebAssembly. So the difference with Rust, obviously, is that you just get the code. Ish.
Well, the problem with Go is that you have to use Go.
Actually, there's a really good YouTube video out by a guy who does a lot of Rust, and he just does like a 20-minute video of he implements a small concurrent program to read text files and count the amount of words in each one. Does it in Go and then in Rust, and he actually works in Go for his day job. He's learning Rust. And at the end of the video, he's basically like everything about Rust was better. Like there wasn't a single element about it that was good in Go compared to Rust. And he actually, as he was building it in Go, he was showing you every error along the way that you have to find at runtime. The compiler doesn't help you with. So it's quite an interesting video. I'll link it after this. Okay, so I'm just going to skip over some of that. Updating a crate to get a new version. This is really stuff when you've been using it for a while, I reckon. So let's get to the actual usage again. So now this is the interesting bit. How do you use that package? So back in your file, you would bring it. Then create rand. It's basically saying that's what it says on the tin. Then crucially, that will bring into scope things that the rand function exports. Again, we can't go too deep into what that means exactly, but you can just know that it exports a namespace rand, and then there's a method in there. Well, I guess this will be a struct. How would you say that? Is that like, because that is going to be a...
I think if it's uppercase, then it's a type, right? It can be a struct, right?
I think RNG is actually a trait.
Yeah.
Could be a could be a trait.
So
structs are also uppercase, right?
Oh, so it's the number.
so
yeah. Okay.
yeah. So I guess that's, so rand ends up having this method, and I think the reason that's there then, if it's a trait, is that you have to bring a trait into scope if it's being used. That's a very deep topic that is way out of thing for now, but
So
basically
a trait is like an interface.
Yeah, but there's...
If you want to call a method from that interface, then you need to import the interface.
Yeah, but I think the point I was trying to make there is that we're not actually using that RNG there, like you say, because if it's a trait, it'll be because something here is using it behind the scenes. That's one thing that threw me really off when I was doing stuff with futures, is that the only reason that's there is because the program probably wouldn't compile that way, even though we're not using it, because you have to bring traits into scope, even though you've not used it explicitly yourself.
Are you not using?
Yeah, that.
The functions.
Yeah, but
You're using it implicitly here because the RNG trait is what provides the gen range method on
Okay. So you are using the function explicitly.
the function explicitly, yeah, but we're not like using that type there. Like we're not typing those three characters anywhere in the program.
Okay. So if you have to call that trait, then the gen range method doesn't exist.
Exactly. Yeah.
Yeah, because it's like, yeah, that's the concept of adding methods on the fly, I guess. Awesome, yeah. I learned that through a lot of pain because I couldn't figure out why the compiler was like saying it needed this thing in scope, and I was like, well, I'm not using that thing. And it turned out that I was, but indirectly, and it needed to be in scope. By the way, side note, you can put that use statement anywhere, because sometimes you might have. Let's not go into it. I've just realised babbling. Yeah. So the next bit of the code is actually generating that random number. So let's just copy the whole thing and get it working. Rust is deep. So yeah, so we see the double colon, so we know this is a namespace. I guess I always call it namespace. I don't know if that's the right term to use. I would class it as a namespace because it's like the leftmost bit, and then or just a module. It's probably the easiest way. Then we're calling a method that's exported from there, and then calling a method that it has on it, and we're going between 1 and 101. So yeah, that's going to create as a random number. And I should print that out. In fact, if we just go like that, see how far we get. So the first time we run it, look, it's going to compile, but then that'll be cached. So now we get the secret number of 63 there. So yeah, we've brought in an external package. Obviously, the great thing there is that all the types and the safety guarantees you get on your own Rust code also apply on every package as they go out. And as your code goes in and out of these packages, it's all verified along the way. So that's important if you've ever used TypeScript, for example, because the amount of times you just end up saying any on some external library, and all of a sudden you've polluted your code with the any type, which is like basically throwing away all your types. So in Rust, that doesn't really occur, thankfully. So we've imported the rand, called a method, got a secret number. Now let's go back to where we were. Okay, so we're not actually using it yet. Let's just make sure that everything's right. So let's say 80. And it says you guessed 80. Okay, so any questions on any of that whole thing in terms of external crates or methods, or even if you've got a question about traits? I'll pretend I know what I'm talking about. Cool, let's leave it there for that then. That's good. So we've got the random number now. Oh yeah, so I'm not going to dive into this because we're going to be here all night if we do this. Just know that methods can be almost added on the fly. Third range function, yeah. We just got a random number. Oh, this is a good one, yeah. So I've just been using this. So Cargo Doc is saying that you can use this tool. This is interesting. So it's going to look at the actual program that you've wrote so far and generate documentation for your program plus the packages you've used. And you can see that actually, so this is not on the internet anywhere. Look, this is actually on your local, and we've got the entire documentation for the rand. So imagine you're on a plane or something with no internet connection, and you needed to know what things you could do. Well, here they are. Interestingly, just quickly, just for my own benefit, I guess, because I'm still learning all this stuff, that's the thing that we imported, and it meant that some methods got implemented. So we use that gen range. So that's what I meant before, is we implemented this thing, but we didn't use it directly. But it's because it modified or added a method to, yeah. That's why that works. Yeah, so this is the bit that threw me off, look, when I was learning it, is that, see in this example, like you don't actually use that yourself. You don't explicitly use it. And that, what I mean is, when I say use it, I mean like that actual identifier there, like RNG. It's just, but you have to import it in this case, otherwise everything won't work. So it's just something to be aware of. I like
the documentation also gets super easy to read as you go along. It's like, I remember feeling daunted by those function signatures.
Yeah. Yeah, it's like learning a foreign language, right? At first you don't know any of the bits, then you learn a few of the words, and then all of a sudden you can take it in and read it all. Definitely.
Probably worth mentioning the reason this trait exists is just because the random trait has several kinds of random number generators. It's just by giving them all the same API.
Oh right, yeah. Yeah, that's a good point.
Yeah, I think the reason you have to import it is because depending on what trait you import, you get different behavior, like you said. If the struct implements different traits or with the same APIs, right?
Yeah.
So if you import one and call that function, it's gonna.
And that's why it's good. That's why it's good that you can put this use statement anywhere, even inside like a block, anywhere that's anywhere that's classed as a block in Rust, you can import that, and it will only take effect for that bit. So you can actually import a different one if you wanted to in another block and get different behaviors on the methods. I don't see that much, I guess, but like, yeah. Adding 2 more lines. You won't know which. Yeah. So he's saying, yeah, you won't know which traits to use and which methods and function calls from a crate. Oh, sorry, you won't just know which traits to use and which methods and functions to call. You got that cargo doc open, which we just ran, which is pretty awesome. Second line prints the secret number, but obviously we need to delete it from the final version, of course. So now I've tried running the program a few times. Well, we've already run it, and we saw that we got 99, and our guess was 80, so we can skip that. So now comparing the guess. So now we have the user's input and we have a random number. We need to compare them. So a pretty simple programming problem, but it's going to give us some more interesting stuff from Rust. The step is shown in listing 2.4. Note the code won't compile yet. So let's take this over. So we had
order. Yes,
well, I had to tell it to, but yeah, it imported it.
Nice.
Sweet. How's that going to work? Because that's a string. Okay, let's just carry on because I think it already said it's not going to work. Okay, I'm going to use this as a guide to explain it. The CMP, of course, Rust likes to abbreviate everything, so the comp method compares 2 values and can be called on anything that can be compared. Takes a reference to whatever you want to compare with. So here it's comparing the guess and the secret number. Then it returns a variant of the ordering enum we brought into scope with the use statement. We use a match expression to decide what to do next. Okay, we can explain ourselves. So if you think about this normally, you would say, well, I don't know how you would think about it, but you could say because imagine that the 3 goals here is to print whether you guess too small, exactly correct, or so you've got 3 things, right? So in something like JavaScript, you would normally say if guess is equal to, guess is less than secret number. Just doing some code in place here to make it, yeah. Then you print whatever, and you would end up sort of having these things. Guess is equal to or above. So there's your 3 different things, yeah. You've got 3 outcomes of this comparison. There's different ways of doing it. You can do it with a switch statement or whatever else. No, sorry, your switch statement won't really work there. But the point is you've got 3 conditions to deal with. It's not just like a binary like yes or no. You've got to deal with 3 different things here. Obviously, Rust has got a way of making this quite succinct. And that's with the match statement. The match statement takes an expression to the right-hand side. It can literally be anything. It can be a value. It can be a function call. Anything that evaluates down to something else, I guess. Yeah, an expression. And then you provide, this is called pattern matching. So we can provide essentially the comparisons. This isn't going to work, is it? I don't get how you compare 2 strings.
I think further down it says this won't compile because.
Yeah. Okay, so let's look at that then. So yeah, so let's just say why I didn't think this would work is because we know that everything that comes from standard in is a string, and the secret number is going to be a string. Oh, sorry, the secret number is going to be a number, like an integer. Yeah. So that's the problem straight away there. There's a type mismatch, so you can't compare those 2 things. It says that an expression is made up of arms. So you hear that term a lot. So an arm would be like the right-hand side there. So the arm being, is the whole thing classed as the arm?
I think so.
Yeah. So it's like, you would say that, yeah. An arm consists of a pattern and the code, yeah, that should run if the value given to the beginning of the match expression fits that arm's pattern. Basically, does the thing match the thing? We can simplify this in a second just with simple numbers, but Rust takes the value given to match and looks through each arm's pattern in turn. That's the crucial bit there, is that it's ordered. It's very important that the first thing is the first comparison. So if it hits that, it isn't going to look at the others. it's like going back to those 3 ifs, but then imagine the first one matched. Well, what do you do? Like you'd have to return early there or something to make sure the others don't run. So this is a way of condensing all of that imperative, like checking of values and returning. It's a way of condensing that down into just the thing you care about, which is the comparison all on one line there, and the 3 possible outcomes and what to do after each of one of them occur. That makes sense.
To me, it helped me like think about it as a switch statement in the beginning. Yeah. It has important differences, but it still behaves like a switch statement in the sense that it's going to take one after the other in order.
Yeah.
It has important differences that we'll get into.
Well, I think so crucially, like if you used the switch statement before, actually, like in JavaScript, so like
JavaScript, I think we some, yeah, I did some when I was writing, I think, purpose stuff.
you can't actually use that as a function. If you give it a value, but then all you can do is match exactly.
Yeah.
So you could say case like, I know this is not, but you could do something there, then you'd have to break after each one, or you could return, then you could have a default at the end. Actually, no, this is worth typing out. So then let's say you return, well, this will show you straight away. So we can't do a range here. We can't say between 1 and 2. Obviously, these are strings, but let's do a 1. You can't say here between.
Value will that not work? In PHP, it does work. But yeah, it's really hard.
Well, I mean, in JavaScript, you just can't encode this. I'm thinking about it now. You just can't do it because.
Kind of range.
Someone can, because you compare functions.
Yeah.
So it is equivalent to a number.
Yeah. Anyway, look at all this boilerplate. Like the point is there, you've just got 3 possible outcomes.
Yeah. The huge difference in Rust is that if you miss one of the possible cases, it won't compile.
Other thing is that you can do pattern matching as well. You can extract values from an enum in one of the apps, but the main you have to think about it for me in the beginning.
Okay, so let's get to this error, because I'm like I say, this isn't going to compile, and it's because the types are mismatched. Yes. So we've said that, boom, that's an error, and it's because one's a string and one's an integer of some type. So it's a mismatched type. You can't do that. Rust has a strong static type system. It also has inference, so like most of the times, well, some of the time you don't have to tell it what types they are. Like in the code, it can figure them out from your usage. We saw that earlier with the let x equals, and if you do a 10, I mean, if you just do that there, like let x 10, Rust knows that what type that is. Just like if you do that, it knows what type it is, etc., etc. So that's all it's saying there is that when it can, it will infer the type, so you don't have to prefix everything with its type. Sorry.
I thought you had to prefix everything.
Nope. And it can do some magical things. Like sometimes Rust can infer types that you can't even write yourself. No, it's true, isn't it? Like enclosures and stuff like that. Like if you, the amount of lifetime and other things you have to deal with. So yeah, it's really strong on type inference where possible. Few type numbers. Let's have a look.
You can look ahead as well and see what's going to be done in the future to figure out the types. Because you can create a vector, let's say what type is in the vector, and then it figures it out as soon as you push something into the vector.
Oh yeah, that's pretty cool. Yeah, so for that, it's like imagining. Where's that coming from? One of the biggest causes of error, like you would never. Well, I hope no one here would ever do this, but like you never ever have. In JavaScript, like an array of some strings and some numbers. Like you don't tend to do that ever because it's just bad. It's hard to work with, so you just don't. It's not ergonomic and it's buggy. So you never have this like type mismatch inside an array. And the point that you're making there is that Rust, you can say, you just create an empty vector, which is like an array in JavaScript kind of, and then You don't have to like, I mean, technically you could annotate this with like the thing that's going to go in it. So let's say you want to have a vector of strings, but look all like, it's like syntax soup, right? It's like typing just for the sake of it. When Rust knows that if you go down the line and push a string in there, new or from? What it's saying there is it goes. Is it? Why is that not working there?
We just took a from.
Oh yeah, new is like creating an empty one ready to push onto it. But, so crucially, there Rust has said right, v here, and it's moaning because it's not mutable, but it's saying v here. I don't know what's going to be in this container. Don't know what's going to be in this array. If you like. So I'm going to look later on in your code. That's what we're getting out there. I'm going to look how you use it later, and then I'll assign that type. So crucially, you couldn't use it two different ways, for example, because then it will say to you, well, I can't infer the type. Then as soon as you put the type in place, it will say, well, now you've used it differently in two places. So it's like, bro, I'm gonna guide you to the right answer one way or another. That's an interesting point. Ultimately, we want to convert the string the program reads into a real number, because obviously to do a less than, equal to, or greater than comparison, you need to have two numbers, or two types of numbers that can be compared like that. So it's saying here we need to convert the string into a real number so that we can compare it numerically. And we can do that by adding the following two lines. So it's going to be read line, it's going to be this bit. So this is getting some real Rust magic because of the way it does. Okay, so there's a few things going on here, which is crazy. Oh, hang on, have I done this the wrong? I don't think I need that anymore, do I? Hang on, what have I done wrong there? So still have the. So we first use this name up. Again, this would be bad practice in JavaScript, but it's fine in Rust. We've created this mutable thing, which the readline thing takes in a mutable reference to it. It writes to it, so you can think of someone who's just literally pushing characters onto it, or maybe it's done in one go. So at this point in the program, guess is still owned by this outer scope, but it's been changed. Then we say let guess again. And because the Rust type system is so strong, it allows you can often reuse variable names called like shadowing. And like you can just do all these kinds of things because it knows the lifespan of everything. So you can, because normally in JavaScript, think of all the times you end up coming up with like funky names just because you've used that name before and you're like, damn, I really wanted that exact name again. Yeah. You don't have to worry about that in Rust because it will make sure you do the right thing. But crucially here, you're essentially saying what this type's going to be, and then you call parse on it on this guess. So guess here is going to be a string. Strings have a trim method. They also have and then by casting this to a U32, it gets the ability to call parse.
So I think that's what it's casting is there's an implicit type parameter in the parse method, and because you said that the answer that you want is U32, it implicitly passes U32 as the type parameter to the parse method.
Nice.
So you could instead write it as like guess equals get.trim.parse turbofish operator U32.
Oh yeah, so like, yeah, which for learning is probably a better way actually, like that.
Yeah. So parse method, you can implement different parse methods for different types, right? Yeah. So there's one for each type, and then once you give them the type, they know which one. Yes. Yeah.
Nice.
Nice. Cool.
Can you move the print one? You get back to the read one. No.
I think it's got duplicated.
Oh,
okay, yeah. So the point here is that parse, I'm guessing, so then it doesn't exist on a string until you, yeah.
So it's really specifying to the parse method what type you'd like it to return.
Nice.
That would work with any type that implements the from string trait.
Yeah.
Right. Okay. It's a generic function.
So it's essentially syntax sugar, isn't it? It's to make like doing this is I'm guessing you could do all of that manually, like type it out in a more
the most way. But I mean, what I was watching a talk the other day showing you that even like these method calls, not actually that much code to desugar that. Like Rust never sees that as a dot parse. Obviously, it sees it as the original trait, and then I don't want to go into it, but it's not as.
You want to, but
When you see what I was going to say, when you see what it compiles down to, it's actually easier to understand. That's what I was learning, like what the traits are behind the scenes, and it's like when you see the desugared version of this, not that hard. It doesn't seem that hard to wrap your head around. But yeah, thanks for that. That's a great example of something that, yeah, that Turbofish thing can go there. I don't know which one I prefer. Actually. It's a great name, right? I don't know why, because I don't think it looks like I don't think it looks like a fish. But
It's like, okay, fair
It's
enough.
a fish that goes fast, obviously.
Like, because of the way the graphics.
yeah, it's something to do with that. You often see it used actually when you first learn, and I used it most for like getting a collection of strings, and then like, yeah. Well, anyway. So now the point is, now we can compare it, because the comparison is going to be on a number versus a number.
Yes.
So the secret number is 14. I'm going to guess 13. Too small. So you see, the this less than thing is kicking in, and we're only getting to this one, and we never actually execute the other two. So that's the important thing we're trying to learn here, is like matching on an enum. Is that it's the first one. So if we go to 29, it's going to print you win because it got all the way down here. And if we run it again, I guess 90, too big. So the best point there is that from this ordering enum, there must only be 3 variants, because otherwise we would have had to implement something else. That's right, yeah. We haven't had to catch all at the end or anything like that. So I don't want to get into that topic right now, but or is it worth getting into that topic? I don't know.
yeah, I think it's worth mentioning that you need to check.
Okay, yeah, let's.
possible outcome, right?
Yep. So before we said that it's like having 3 if statements, one after the other. Is it less? Is it greater than? Or is it the same? And imagine that if you were to comment out one of those because you're debugging in JavaScript, the other 2 would run, and you could nothing's going to stop you just putting that to production, even though you've commented out one of the conditions, and it might be the mission critical condition. And the point here is that if I delete that one, for example, which might be like fire the missiles, Rust is going to say nope, because there's a possible outcome of this comparison that you haven't catered for.
Jeez, man.
So you see, it's way stricter, but it's for safety.
Just understand, like, how does it, alright, how does the language know that?
Well, it's because, so again, that's because, we've called match, and well, I guess.
So the compare function returns an enum.
Yeah.
And the enum has 3 variants. How it knows.
Is it?
An enum has
hang on. So
a limited number of variants. So it can either be less, greater, or equal.
Oh, okay.
yeah.
It's defined.
So if you look at it, so I've just like command clicked on the actual CMP compare method.
Yeah.
And it tells you right there that it returns this ordering. So you see that's uppercase O. So that's like an enum. And then enum is like, it's an enumeration. So it's just something that you can that can have multiple variants, I guess, and you can like enumerate over them. And the point is that there are 3 of them. So if we were to look in their code, there'll literally be a bit of code that goes like this: enum ordering. I'm not going to type it all out, but it'll be like less, greater than, and something else, right?
Okay, cool.
So it's in this case, it's actually a really simple one. It sounded like magic before, but it's really just saying this line gives me one of these, and there are 3 things to check. That's the best way to think about it in this case. It gets more complicated, and there's other ways of matching, but for this simple case, it's just literally enforcing that you make sure you check them all.
All the 3 of them.
It's the foundation of a lot of the safety, to be fair. And you just bring that one back. Oh yeah, and actually, before we bring it back, if you don't care about what it actually is, you could do another, like a catch-all.
If you actually were comparing a number, like say match number, you actually also have to take that it's every possible integer out there.
Yeah.
But
Or you would just write it.
you can have like a default.
Okay.
So you would say if it's 1, do something. If it's 2, do something.
Yeah.
If it's anything else, then
Yeah, so you still do it that way. You wouldn't try to write like every single
Yeah.
number. Or,
No, but you can have. Well, then you can have ranges and
but
stuff.
you still need to make sure that every possible one is included.
okay, so you still give it the range. Okay. So that's why the
What was the
capsule is the thing.
Yeah, that's right.
So that makes sure it's all
Equal.
true.
That's like anything else.
Yeah. Cool.
I love match statements and just a whole programming model around it. I could talk for hours on that.
Equal means you win. By the way.
Sorry?
You win.
Oh yeah. Sorry. Da-da-da. Right. Parse method on strings parse the string into some kind of number. Because this method can parse a variety of number types, we can tell Rust. We need to tell Rust the exact number type. This is what I love about it, because I've done a lot of TypeScript, and it's like it's very different because in Rust you can influence how the program actually runs based on the types. So when we say type, we mean like every time you see a colon, then something like U32 or string or something. That's the type of it, and you can influence how the program actually executes based on that type, which I'm guessing is all done at compile time. But the point is, inside your code, you can change the way it runs. And the call to parse could easily cause an error. So that's why we had to unwrap the parse as well. Look, let's do that. Oh yeah, actually, that's a good example. So this is what I'm talking about. The type on the left here is telling Rust how it's almost changing the program, because in a sense, now if I try and do an F, the whole thing is just going to panic, which is like a safe way of crashing, I guess. And it says please type a number, because that's the string we type there. So you're essentially getting like type conversion for free, I guess. That's one of the, in this case, string to number. It's not as simple as it sounds, especially when you get into UTF-8.
Error method that you put in as well, right? The expect is type number is showing us what are the errors.
It is, yeah. So that's printed there, but then you get the whole stack trace because it's a panic. Which, yeah, I think there should be a way of suppressing some of that personally. But again, as the Rust book says, the real thing you should do is implement error handling. Expect and panicking is just for, I think, for dev when you just start learning and messing around.
I think there is a way of turning off back traces from panics as well.
Is it?
Yeah, it's an environment variable, I think.
Nice.
They do it in Martin.
Nice.
Rust underscore backtrace equals.
What would you say? An environment variable?
Yeah, you can say
Yeah.
Rust underscore backtrace.
Okay.
Before you win it.
I don't want to get too lost on that, because I've actually got to leave it in 15 minutes, I'm afraid.
Right.
So yeah, the parse method. So we just saw there like going from a string to a number. So that's really cool. That worked. Oh yeah, so we skipped over that, but basically because we called trim first, it would have got rid of any spaces. So if I just run it again and I type like loads of spaces like that, and then 56 and loads of spaces, just like string trimming in all of the languages, just basically it's going to go take regular like white classes as white space characters and get rid of them. So nothing too exciting about that. Now let's do multiple guesses with looping. So this is what we already have. Oh no, sorry. The loop keyword creates an infinite loop, something we normally want to avoid. We'll add that now to give the users more chance at guessing the number. We moved everything into a loop from the guess input prompt onwards. So it'll be there, won't it? That's the line that blocks based on input. So we don't want the machine to blow up.
When you want to generate a new string every time,
Is it carrot?
will it append your
Yeah.
guesses otherwise?
No, it overwrites when you've only got move one.
Oh, okay.
All right.
Will
That's
it
good then.
clear, you think?
Or we'll
Try it. Try it.
as you can see, we've moved everything. The user could always halt the program by using the keyboard shortcut Control-C, but there's another way to escape this. Oh, I see what it's saying. It's like, so right, let's try and run it anyway. So basically we've just put it through this loop, just going to keep executing everything inside here over and over again, forever and ever and ever. It's never going to. The point is though, it's never going to stop, even if you get.
It's not stop. That's not gonna work.
Yeah, it is.
Because your guess is now an integer, right? You passed it. You saddled it.
Please type a number.
Oh yeah.
So what? Sorry, I'm missed
So you
that.
shadowed it with the 32.
You basically have to move the guess string new to the beginning of the loop. So every time it has a press.
Oh right, cool. Oh yeah.
Otherwise, the second iteration is an integer. And you're trying to read the line into an integer.
That's really good.
That's similar to compile actually.
I don't think it's really good with loops.
Maybe.
Rust is good programming language, but it's not very good at loops. Yeah, that works.
I did compile, yeah.
Oh, it's given us, yeah, showing us the error here. Typing quick actually quits the game. So.
Oh, okay. Oh, yeah, of course. If you type anything that's not that unfair.
Oh yeah, so okay, so we've got that. So now it's saying like, okay, we can actually get out of that loop. So at some point we need a way of saying stop looping, I guess, because if you look on the right there, my program's still executing. Look, doesn't matter how many times I get it right. We'll stop it and we'll change this. So what's good about these match things is that even though this is on one line, it's like you can open up a block. Same thing. Oh. Goes up there. But then we can say break. Because anyway. Cool.
It's a tough game.
Especially when it tells you the secret number straight there.
Surely we must hide the secret number.
Secret number is 43. Input your
okay.
guess. 34. Too small. Too small. Too small. Too small. But then if we get 43 exits, and crucially, so this break keyword is part of the loop, so it's stopping it. And that's it. That gets us out of the infinite loop.
Nice.
Yeah, I guess as with all loops, there needs to be a way of stopping it. You'll most likely come up with, like in JavaScript, you'll have like a while loop, for example. That's quite a common thing. Like if you're walking back up the DOM or something, you have like a while statement that keeps reading in parent, and eventually you need to have a condition where it becomes false at some point to stop, to quit the while loop. And I guess this is one way of doing that. So I wonder, can you have on that note, do they have while statements in Rust?
Yes.
Is it? Yeah. Okay. Well.
That's one way of using the while statements.
All right. How have we got that going then? Oh yeah. So you got the actual.
Using actual condition.
Yeah. That's just how you expect it.
Well, guess not equal to secret number. If guess is less than target, if too low, it's too high. Guess another guess.
Nice.
You can also name loops.
Oh, and then break.
Yeah.
Where would you name it?
I believe it's after it. I've never actually used it. I've never used a loop.
Dude, you can't tell us about a feature and then not tell us how to use it. Loop. Well, surely it's going to be.
I believe it's. It has a dash in it. It might be after or before.
Every language needs a go to, right?
There you go.
I know.
It's not going to be that, is it?
That's a good name.
Single.
It's what?
No,
Like that?
Yeah. About the about the end one, yeah.
Yeah, but that's not a lifetime. Isn't it? No, I'm not saying you're wrong. I honestly don't know. I'm just like,
I can't remember exactly.
It's physical labels.
loop labels, yeah.
Yeah.
Where do you put the what's the syntax?
It is like a lifetime.
Oh.
Prior to the.
Yeah.
Prior to what? So before it, like this.
No, on the same line, right? Yeah, on the same line, but before it.
The example is a
Once-
for loop.
Simple code, and then put your name and then a space. That's it. That's it.
There's a code as well.
A column, yeah, sorry.
Oh, yeah.
Call S.
I knew it was like before after.
So what? But then how do you break on S?
You need to put the like that.
JavaScript has this too.
Is it?
I believe so. That Python one has it.
Nice. I don't know. I've never
You
seen
can
it.
break by number. I think.
Yeah, it works.
Yeah, JavaScript does have it for if you need to break an external loop from an internal loop.
Nice.
Number.
I think that's actually a good idea because sometimes you do like you end up with nested loops. I guess maybe I've never thought of using anything like that. To be honest, I've never actually used that loop keyword in Rust anyway.
I only used it for average code. Lots of things I only know because I had to do something.
The next thing, what time is it? 10 minutes, then I've got to go. Right. The first to further refine the game's we're right at the end actually. To further refine the game's behavior rather than crashing the program. If the user inputs a non-number, let's make the game ignore a non-number so the user can continue guessing. That's a good idea. So, oh yes, this brings on to one of my favorite features by a mile.
Really cool.
It's so good, yeah. So if we look at this bit here, when we said that this could fail, and we want to say that the point of this part of the book is saying it's not a good experience to crash the program. You want to just say, try again. So we have to do that unboxing thing that we talked about. How do they do it here? Yeah, just with like an inline match. So it's like if we saw was an actual expression, so is match. So we can actually go here, match, and then the result of the matching arm is going to be assigned to the value, as you can see there. So we'll type it out because that will help us learn it a bit. So so because this returns a result, which we know by looking at the type that it returns.
It's an enum, by the way.
Yeah, which is another enum.
Like ordering, but with two variants, okay or error.
And we can destructure, I guess it's called, the value. Let's call it T. And just return it. And if there's an error, what does it say to do for error? Just continue. Yeah. We'll make this match. Error. Interestingly then. Oh, sorry, yeah. I say, can you do a word there? Can you also do new? Okay, so the point here is that we can unpack. I mean, there are definitely better ways of doing it. This example, but it's when I still do this now. Actually, this what I would say is when you write a match like this, you're doing it the longhand way. Like it's the best way to learn, like to figure out the types and everything. And like I had a post on Twitter not long ago. Did you see that one where like I had like I think there was 6 or 7. Like basically, I was like taking a URL, parsing it, picking out different bits, and it ended up being about 6 or 7 levels of nested results and options mixed as well. And I actually deliberately wrote out it in the most verbose way first to make sure all the types lined up because I was getting loads of errors that I couldn't figure out. Then I went back and refactored it. So just like I would say this is super overly verbose for what it's doing, but there's always ways of doing results and options in a cleaner way. But anyway, I digress. And point here is
So when you run that, it will just skip invalid input.
You just go back to the beginning of the loop at that point.
so if we get 12 is there, 27 would win. So I'm not going to type that. But then if we did an R, just ignores it.
I mean, the
So you just put
the print line should also be in the beginning of the loop. Right,
The what?
The one above the loop.
put your get.
The one at the top. Say that every time.
Oh yeah.
Just look for
Nice. Okay, so let's run that again. So it's 21. So if we go 12, it's wrong. If we go that, input your guess.
yeah, so it's come back to the beginning of the loop.
Yep. And obviously in here you could, of course, open this up. This is the bit I love is the fact that it's just a regular block of code, so you can do anything you want. So we could print line in there that you had an error to be a bit more of a. Oh, sorry. Let's just do a regular. Yes, you don't need to return that. But in fact, that
Yeah,
how did that work before?
it knows. What do you mean you don't have to return an integer?
Well, normally, because normally both arms have to match. The return
Yeah.
type has to match, but
it's
surely they're not
it's
matching.
smart enough. It's smart enough to realize that you're not returning, you're skipping.
Must be, yeah.
Because I was doing this the other day in an app that I'm doing, and if you exit the process at that point, it also is smart enough to really compile.
Nice.
I think behind the scenes continue returns, especially for the never type.
Oh, nice. Oh, yeah. I've used it never in TypeScript, so I'm familiar with that concept. But you can't actually use the never. There's no type you can use called never, is there, in Rust?
I think there is. It's called exclamation mark.
All right.
Yeah,
And
you're going to be able to
you should be able to return.
Wow. Sweet. So yeah.
If you remove the continue line, you won't compile.
Oh yeah, that's for definite, because print line is going to return. Yeah. Well, even if you did that, so what does print line actually return? Oh, just is it unit? How do you say that? Unit type. Cool. So the point here is that when you say equal, match, it's like, you can think of it, I always, when I was learning this, thinking of that as like you can think of it being wrapped as an expression almost, because it's almost like that could be a separate function. And that's how often what you do is you end up extracting that to a function, and the first word is matching the function body. But the point is that match itself can produce a value from one of the arms. So you can just have it directly in line like this. And when it gets too big, you just end up refactoring it out.
And the error that they're talking about is that Rust requires you to return the same value out of every match arm, which is a common mistake in switch statements, where you return like a value of a string, and then you return like a null, and you return something else. Yeah. And then you've got handling code that then just falls over. Rust is requiring you to return the exact same type and then match the type.
Yeah. So you're imposing restrictions on yourself essentially to. Yeah. Parse is not able to turn the string into a number. Blah blah blah. Yep, it's been through all that. Pretty good. Nice.
That's the final code.
One final tweak. We call the program is still printing the secret number. That works for testing, but yeah. So then that's it. We got to the end. That's a genuine program. No external packages. Some core Rust concepts. Pretty cool. I learned some stuff. Definite. I always do. So yeah, I think that was pretty good for the first one.
Nice.